All right, so we just did the whole notes on basic identities, basic trig identities. Now, this time we are going to take those basic trig identities that we learned and we're going to do verifying. So we're going to make one side equal to the other side using those trig identities that we've learned. So hopefully you know them and not just, oh, we learned them yesterday or we went over them the other day. Make sure you know them. All righty. So let's go into example 1 where we're actually going to start doing that. So first off, it says verify that secant squared x minus tangent x cotangent x equals tangent squared x. Okay. So with that, before we do anything else, we need to realize, okay, we need to make a plan. All right, we need either to work on the left side and simplify all that down to get the tangent squared, or we can work on the right side and try to work that out to get what the left side has. And I would always say use the big side, one that has a lot of stuff going on, use that to get to the smaller side. So I would say work on the left side here to get you your right side. So I would work on this left side right here to give me tangent squared x. Now, with this, we have a bunch of trig identities and stuff that we need to have and know and everything. But here's one thing. We know we need to get to tan squared, and we have a secant squared x. Isn't there a trig function or trig identity, that deals with secant squared and tan squared? Is there one? Is there one? Is there one? And there's a Pythagorean identity that has that in there. A Pythagorean identity, but do you know that Pythagorean identity? Do you know that one? Or do you know about that one? Okay. Well, everybody should know that if you use tan squared x plus 1, it equals secant squared x. Okay, so we have secant, and we have a tan that we need. So maybe we should use that at some point in this thing to go ahead and work it out. Okay, so let's try that. And also, let's do some other stuff. We have tangent, we have cotangent. Can't we kind of do something there where they have something in common where we can get something to cancel out maybe? Okay, so we have tan in here, which is 1 over cotangent. And we have cotangent here, which is 1 over tan. Oh, there we go. Pull up. Come on. There we go. 1 over tangent. So we have all that going on. So maybe we can use any of those three, or maybe all three of them, or some parts of those three to help us work this problem out. So let me deal with this part here. And it's up to you. You can actually deal with this part if you want to, or you can deal with that. It doesn't matter, as long as you can work it out. But we have our identities, and let's just try stuff. So if we're wrong, we'll just erase it and then start over again, or just crumble the paper and throw it away. Okay, and it's okay to do that. That's perfectly fine. So I'm going to keep the secant squared here right now. And let me change everything for the cotangent over to tangent. So cotangent x equals 1 over tangent x. And again, we're not sure if they're equal to each other, so I'm going to put a question mark right there. We're not sure. So here, let's go ahead and say, since it's a tangent up top and tangent up bottom, let me rewrite this so everybody can see it. We know this is over 1. So if we multiply, that'll be tan x over tan x. And this is minus secant squared x. And that hopefully will equal tan squared x. All right, so anything over itself, we know that's 1. We already know that part there. And we have secant squared x equals tan squared x. Okay, so we have this going on. Now, the biggest thing to understand is that you can manipulate your identities here. Ooh, there we go. We can manipulate this identity here to give us what we need down here. So as long as it stays in the identity, you can manipulate, you can move things over from one side to the other and all that good stuff. So if I were to say, let's subtract 1 from here, that would give us, let's see, I'm running out of space. Tan squared x equals secant squared x minus 1. Right? Because if we subtract 1 from both sides here, that would cancel out. So you're left with just tangent squared on this side, and then secant squared minus 1. It's just that. Okay. So if we can manipulate it, tan squared x equals secant squared minus 1. And wait, we have secant squared minus 1 right here. What? Okay, so if we do that, isn't that tangent squared x? What? And they equal each other. Look at that. Look at God. Look at God. And so therefore, it is true. It works out. So therefore, it is an identity. So we just verified it. Bam, booyah. Now again with this, it may take time to figure out how to do it. I use identities that I know the identity, so it makes it easier for me. But if you don't know them, then it's going to make this really hard for you. So make sure you know them so you can be able to apply and then work things out. Okay, so that's example 1. And then I'm going to give you a practice that you can actually work on.